Your FastMCP server needs Azure AD protection, but you want the simplest working configuration without manual token handling or complex setup. You'll see how to use environment variables for a complete development setup. Just set your Azure apps cliented, tenanted, and required scopes, and FastMCP handles the rest. The example shows the minimal code needed when using environment-based configuration, where the FastMCP tool decorator automatically enforces authentication and validates that incoming requests include the required scopes defined in your Azure App expose and API section. We'll also note where production deployments might need additional configuration, like certificate-based authentication or persistent token storage for server restarts, while keeping the focus on the clean, working example that's complete as shown. From FastMCP, import FastMCP. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals Azure Secured App. FastMCP tool. A syncdef protected tool query, SDR. A tool that requires Azure authentication to access. Hash your tool implementation here. Return processing authenticated request. Query. This demonstrates the OAuth provider pattern, where FastMCP encapsulates Azure AD's authentication requirements through a configurable provider interface. The code shows how enterprise-grade Azure authentication, with mandatory tenant specification, scope validation, and JWT verification, can protect RPC endpoints while keeping tool implementations clean. The key distinction is how the framework handles Azure's strict requirements, like tenant restrictions and access token v2, while exposing tools as simple decorated functions that automatically inherit this protection. The pattern works by centralizing authentication configuration either through environment variables, as shown in the example, or explicit provider initialization. The FastMCP tool decorator automatically enforces Azure AD authentication and scope validation for each endpoint, with the example demonstrating the minimal viable configuration: tenanted, cliented, and required scopes that must match permissions defined in Azure's expose and API section. The environment-based approach shown is complete for development when proper variables are set, while production deployments might add persistent token storage for server restarts or certificate-based authentication instead of client secrets. This approach eliminates per-endpoint security boilerplate while maintaining Azure's strict identity requirements. The example shows the simplest working configuration where environment variables handle all authentication setup, making it ideal for development and lightweight production deployments. The trade-off is Azure's upfront configuration, requiring app registration and scope definition, balanced by consistent security enforcement and the ability to focus on tool logic rather than authentication plumbing. The pattern particularly shines when you need to expose multiple protected endpoints while maintaining a single, centralized authentication configuration. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating Azure AD secured tools. The example uses environment variables for authentication configuration, showing the simplest working setup for development when Azure Client ID, Azure Tenant ID, Specific ID, Organizations, or Consumers, and Azure Acquired SCOPS are properly set. The FastMCP tool decorator automatically handles Azure AD token validation and scope enforcement for every call, using scopes defined in Azure's expose an API section as unprefixed names. Production deployments typically require explicit Azure provider configuration with either client secrets or certificates, and may need persistent token storage for server restarts or custom authority endpoints for government clouds. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals Azure Secured App. This initializes FastMCP with Azure Authentication automatically loaded from environment variables, demonstrating the minimal development setup. The name parameter identifies this instance in logs and telemetry, while the @MCP tool decorator later enforces both authentication and scope validation automatically. For production, you'd explicitly configure an Azure provider with cliented, tenanted, specific ID, organizations, or consumers, never common and required scopes, matching your Azure app registrations, expose an API section. While this example uses client secret via environment variables, production supports certificate-based authentication and optional persistent token storage for server restarts. @MCP tool. A sync-def protected tool query, SDR. A tool that requires Azure Authentication to access. The @MCP tool decorator exposes this function as an AI callable endpoint with built-in Azure AD authentication and scope validation. It automatically enforces permissions using the scopes defined in Azure's expose an API section, where scope names are simple strings like read rather than full URIs. This example shows the complete development setup using environment variables, while production may require explicit Azure provider configuration with cliented, tenanted, specific ID, organizations, or consumers, and required scopes. Authentication supports multiple methods including client secrets or certificates, with optional persistent token storage for maintaining sessions across server restarts. Hash your tool implementation here. Return F processing authenticated request. Query. This placeholder marks where you implement your tool's core logic. The @MCP tool decorator automatically handles Azure AD authentication and scope validation using environment variables for development. No manual token handling needed. For production, you'll need explicit Azure provider configuration with either client secret or certificate-based authentication. The example shows the minimal working configuration when Azure Client ID, Azure Tenant ID, and required scopes are properly set in the environment. Azure Authentication Pattern. The @MCP tool decorator transforms Python functions into Azure AD protected endpoints, where authentication and scope validation happen automatically through FastMCP's provider system. Environment variables provide the simplest complete configuration for development, while production supports multiple authentication methods, including client secrets or certificates, with persistent token storage only required for maintaining sessions across server restarts.
The endpoint that never asks for credentials rejects all who lack them.